Hello everyone, welcome back to my channel Learn Business Next. I am your Rohit Dasari. I am pursuing BE from SVC College of Engineering. Today's subject is Mathematics 2 for CSE stream and the subject code is BCS301 and today's topic is Introduction to Markov chain. So good morning everyone. Let's dive into an intriguing concept from probability theory, Markov chain. If you are wonder how Google predicts search results or how weather forecasts work, Markov chain are at the highest of these applications. By the end of the session, you will see how this mathematical framework is both elegant and practical. Let's start with the definition. A Markov chain is a stochastic process, a fancy term for a random process that satisfies the Markov property. In simple terms, it's a system that moves between different states according to its probabilities. The beauty of a Markov chain is that a future state depends only on the current state, not on the sequence of events that preceded it. So for example, imagine a student deciding whether to study or watch Netflix. Today they are watching Netflix. The probability they study tomorrow depends only on today's activity, not whether they skipped class all week. That's a Markov chain. So there are some key terms you need to know. First one is states. These are the possible conditions or scenarios in the system. For our example, studying and Netflix are the states in the above example given by me. Second is transition probability. This is the probability of moving from one state to another. For instance, there might be 70% of chance of studying in the Netflix state and a 30% chance of switching to studying. So third is state space. This is the collection of all possible states. In our case, studying in Netflix. A Markov chain can be represented as a state diagram where states are nodes and the probability of transition are labeled on the connecting arrows. Markov chain's property and examples. Now let's understand the Markov property in detail. It states the conditional probability of transitioning to the next state depends only on the current state, not on the history. So mathematically, if we donate the states as the property can be written as PSA of n plus 1 to Sn to Sn minus 1 till goes S minus 1, which is also equal to P of S minus n plus 1 divided by S minus 1. So now let's see examples where these Markov properties are used. So example 1 is weather broadcasting. Imagine a simple weather system with two states, sunny or rainy. If it's sunny today, there's an 80% chance it will be sunny tomorrow and a 20% chance it will rain. If it's rainy today, there's a 50% chance it will still rain tomorrow and a 50% chance of sunshine. So you can represent this as a transition matrix like 0.2 to 0.28 and 0.5 of 0.5 where the raining will be. Example 2, Google page rank. Google use Markov chain to rank web pages. Each web pages is a state and the links between the pages represent transition. The probability of moving to a linked page depends only on the current page, satisfying the Markov property. Example 3 is board games. Think of rolling a die in the board games like Monopoly. Your position on the board at the next turn depends only on your current position and the die roll, not on where you have been before. So let's see applications in engineering. Markov chain are incredibly useful in engineering. Some examples include first is queuing systems, understanding customer wait times in service systems like banks or call centers, Second is signal processing, predicts noise patterns in communication channels. Third is robotics, designing algorithm for robot path planning. Fourth is reliability engineering, modeling systems failures to predict lifetime of machines. By focusing on current states and transition probability, engineers can simplify complex systems and make accurate predictions. So to recap, a Markov chain is a mathematical model for systems that change states randomly, but with a memoryless property. The future depends only on the present. As we all know, we discussed the Markov property, transition matrices, and real-world examples like weather prediction, Google PageRank, and engineering applications. So Markov chains are just abstract concepts; they are powerful tools driving technology and innovation. So thank you, and feel free to ask any question. Do like, share, and subscribe. Thank you.